Alright, here we go. Okay, so this is an Abacus. It is a counting tool. This counting tool helps me visualize our numbers. Hello everybody, hello. This is an Abacus. Here we go. Oops. Okay, we're going to be working on a 3-digit number maze. That's what we're going to be doing. Hello everybody, hello. Thank you so much for joining. Thank you so much for joining. For those of you that are interested, it is available here in my TikTok shop. Hello. Good evening. Good evening. Oh, no, that's what I want. Nope, we got to do this one. Yep, there we go. Okay, so here we go. Hello everybody, hello. This is an abacus, and it visualizes our numbers. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How do I know the numbers? I know them because there's this dot right here. This dot tells me that this is the ones place. So we actually have our ones, our tens, hundreds, thousands, and our 10,000s. That's it. Every column is represented. Every number is represented by each column. So just like here, we could do 10, 20, 30, 40, 50, 60, 70, 80, 90. And then guess what? We got $100. No, 100. So, hello everybody. Hello. Welcome, welcome, welcome. We're going to be doing a maze. Here's my maze. This has already been done, but we can work on it again because it's fun. It is so much fun. All right, here we go. So, thank you so much for liking the live. Hello everybody. Hello. We're going to be taking a look at this number. What number do we think this is? So I have it's a 3-digit number. So it's our hundreds, tens, and ones. What number do we think that is? Hello, everybody. Thank you so much for liking the live. Hello. What number? So we have 455. That's what that would look like. 455. So then, oh, I did that wrong. It's not 4 because this is the top bead. The top bead is a value of 5. So it's actually 8 because the top bead is a value of 5, and then this is 5, and this is 5. So we have 5 and then 3. This is 400. This is 800. See the difference? So we got to pay attention to the top bead. It is, yeah. So it's actually 855. That's what it is. 8. 5 plus 3 is 8, and then 5, and then 5. Well, we got the 5. And then that would be 8. And then we have our next number. We have our 5 plus 1. That is equal to 6. And then we have 3. That's what 3 looks like. Let's try this one. Never stop. Let's try that. There we go. So, oh, Egg, you really like to spam a lot, don't you? So we have the top bead as a value of 5. And that's it. So our final answer is 635. 635 looks like that. In the end, we do that. So this is for Egg. Egg.
Do you understand the words that are coming out of my mouth?
Do you understand the words that are coming out from my mouth?
Apparently you don't. Okay, so we're going to continue on. So we have our hundreds. Every column is a place value. So we have our ones, our tens, and our hundreds. We have our hundreds, tens, and our ones. When we look at our number, we have 8 and then 3. So 8 plus 3 is equal to 5. We have 2. This is 2. And then this is 9. So we have 9, which is 5 plus 4 is equal to 9. How do we get that? Well, if we did 4, 1, 1, 1, 1, these are all values of ones. This is what 4 is. 1, 1, 1, 1. 1, 2, 3, 4. And then we add the 5. Now we have 9. We could do the same thing here. We have 3, 1, 1, 1. There's 3 ones. This becomes 8. Why? Because the top bead is a value of 5. So this is 5 plus 3 is equal to 8. And then we have 2. So it's 8, 2, and then 9. That's what that is. Hello, everybody. Hello. Thank you so much for joining. See, I don't think it's working. 829, and we get this one over here. So what's our next number? Hello. Hello, everybody. Hello. So what we're doing is we're going to read our next number. We have our hundreds, our tens, and our ones. So we have our hundreds, we have our tens, and we have our ones. That's what that looks like. So the top is the value of 5. The here is again the top beat is the value of 5, and the two bottom beats, those are values of 1. So 5 plus 2 is equal to 7. And then we have this one, 5 plus 3 is equal to 8. Thank you, Israel. Thank you. Yes, 578. Well done. And then we have our next number. So we have our next number. What number do we think this is? So we have our hundreds, our tens, and our ones. So the top bead is touching the horizontal bar. Anytime the beads are touching the horizontal bar, that's what's considered counted. So what number do we think that is? So we have 600. Ooh, almost. 600. 200 looks like this. Because we have to pay attention to the beads that are in either the top or the bottom. So it's actually 600. That's what 600 looks like. We have the 1, and then we have the 5. Thank you, Kiona and Jordan and Israel. Yes, thank you. So it's 615. Did that make sense, Israel? So it's actually 6 and not 2. And then we have our next number. There we go. Cool. Yes. Yeah. You know, interesting. What I would do is the top row always gets to me. You know what I would do is I usually start from the top. So if I see the top row touching the horizontal bar, then I already counted. But when I look at this one and I don't see the top row being counted, then I know that this is 1. That's how I would see it. Thank you, Jordan. Thank you, Ami. Thank you, Kiona. Right? So we have 501. That's what I would see. So I would always start from the top down. That's what I would do. Yeah. Not a problem. Not a problem. Thank you. Thank you for the comment. I mean, if you didn't tell me, if you didn't say anything, I would have never told you. You know what I mean? So, hello, Crazy Train. Yes, it's very easy, very simple. Every number I explain. So when we're looking, thank you, Jordan, it is 597. So we have 5 as the top bead. We have the 5 as the top bead. So anytime the beads are touching this horizontal bar, that's be considered counted. So we have 5, right? These are all 5. They're being counted. The bottom beads is 1. There's 4 ones here, and there's 2 ones here. This is 4 plus 5 is equal to 9. This is 2 plus 5 equals to 7. Thank you, Jordan. Thank you, Kiona. So we have 597. Easy, simple to use, easy to understand. And we're going to keep going. So we have our next number. If you anybody interested, I do have this book available in my TikTok shop, and you also can purchase the book, the Abacus with it. So we have our next number. We have our hundreds, our tens, and our ones. Thank you, Omni. Yes. Is it? Oh, it is not 561. It is 661. Thank you, Jordan. Thank you, Omni, for the... Yep. Thank you, Crazy Train. Yes, it is 600. 600 because the top beat is a value of 5, the bottom beat is a value of 1. Together, this makes 6. 5 plus 1 is 6, and then we have 1. So notice the top beat over here is not touching. Because the top beat is not touching, then it's not counted. That's why it is considered 1. This is 1, this is 6, and this is 6. So it's 661. 661, and it takes us to our next number. There we go. Hello, everybody. Hello. Thank you so much for joining. We have our next number. We have our hundreds, our tens, and our ones. What number do we think that is? Yeah, I don't think so. Is it? It is, because it's 600, right? 5 plus 1 is 6, and then 5 plus 3 is 8. So this is 680 with a 0. 680. That's what it is. So Crazy Train, that would be 580. We want to add the 1 at the bottom, so it'd be 680. There we go, 680. And then we have our next number. There we go. There we go. So we have our next number. We have our hundreds, our tens, and our ones. What number do we think that is? We have the... Anytime the beads are touching the horizontal bar, it's considered counted. If they're not, then they would be considered 0. Thank you, Crazy Train. Yes, it is 450. There you go. Thank you, Monkey's Kingdom, for the share. So we have, yes, 450, right? Because it's the hundreds, the tens, and the ones. So that's what 450 looks like. And then we have our next number. There we go. All right, so we have, this is easy, hundreds, tens, and then our ones. What number do we think that is? Oh, that's starting to get there. Thank you, Crazy Train. See, Crazy Train, easy, right? Simple to use, easy to understand. Not too difficult? Oh, hello, Busy. Welcome back, welcome back. Yes, 909. And then our final answer. So for those of you who are interested, I do have this book available in my TikTok shop. I also do have it available here. My name is Lynette, and I've been teaching Abacus for 20 years. I have a bunch of books available everywhere. So we have our number. What is our number? Very simple, right? Yeah, I didn't know using Abacus was that simple. Yeah, Crazy Train. Explaining this is actually easy. It's kind of, I don't know what's going on. Yeah, so it's 786. Thank you, Anthony, Busy, Crazy Train, Jordan. Hey, Lola, welcome back. Yeah, so right. So what we're doing is we're understanding how to read the abacus. After we read the abacus, we're going to go into understanding how to move the beads and then add, subtract, multiply, and we can divide. Yep, we can do all of that. So now you might be wondering, well, why am I in the middle? I'm in the middle because I have this label right here. Do you see that label? That label tells me that this is the ones place. Thank you so much for checking in. Hello, everybody. For those of you that are interested, there's a little heart me right around here. Please check in. Yeah, please check in for the heart me if you want to be part of my community. It's to show it's to show TikTok that you are a real person. Thank you, Capri Oreo Cookie, for the follow. So, because this is my ones place, I have a label right here. There's my ones, my tens, my hundreds, my thousands, and my 10,000s. That's what that is. And so when we're looking, right, you'll notice for readability, there's another dot over here. No, it's just a label. Just a label. Thank you so much for checking in, Capri Oreo. So when we're looking, right, it's just for readability. This is the ones and this is the thousands. The thousand is just like the comma. So when we're looking here, we have this one. Notice how it's easier to see when there is a comma. So thank you so much for checking in, Lola. We have our 3,456. Make sense? So it looks different if we did it like this. There's no comma here. So it's a little bit harder to see. So if we did this one, right, we could do 73,456.25. So now we have our decimals. That's what this is. There we go. So when we're looking, we have our decimals. Our decimal sits between the ones and the tenths. So that's why we have the there, right? And then Mike is paying $5,000. I don't have $5,000. I have this number.
55 burgers, 55 fries, 55 tacos, 55 pies, 55 cokes, 55 wings, 55 shakes, 55 pancakes, 55 pasta, 55 peppers, and 155 taters.
So I have 55,555.55. That's what I got, right? And so what I did is I did a whole row of fives. So just like this, we have 9. After 9 is 10. 10 is not this. 10, because we're not combining the two columns. 10 is exactly how we say it. 1 and a 0. That's what that is. We don't need to combine the columns. You don't combine the columns when we're writing. You don't combine the columns on the abacus. The abacus mimics the way we write. You can do a whole row of 5s. You can do a whole row of 7s, right? You can even do a whole row of 9s.
99 problems, but a ain't one. If you having girl problems, I feel bad for you, son. I got 99 problems, but a ain't one. Hit me.
Okay? So we could do 99,999.99. There we go. Not expecting that. Right? What are we doing? We're trying to level up our brains, right? For those of you that want to stop brain rotting, you want to level it up.
Level up, 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 level up.
Oh, Jordan, you're interested in multiplication, division? Yes, you can exactly do that on the abacus. But you know what? We don't do multiplication division until I get up to 10,000, and we're only at 900. Is that correct? We're only at 900? What do you see? I only see 900. Is that right? No, we are at 1K. We're at 1K? That's not right. How can this be possible? I don't know. I don't know. I think my phone's lying to me. All right. So, yep, there we go. So, when we're doing, it's just like the tally marks, right? How does this work? This is my first time here. Hello, XI. So we can actually do, you're just in time. We're doing this. So we have 1 on the abacus. We get 1, like tally marks. This is 2, that's 2. This is 3, that is 3. And this is 4. 4, just like the tally marks, right? And then we have 5. We have 5 on the abacus. 5 is like that slash. And then we have 6, right? 5 plus 1 is 6. And then 7. Thank you, everybody, for liking the live. 5 plus 2 is 7. 5 plus 2 is 7. And then we have 8. 5 plus 3 is 8. 5 plus 3 is 8. And then 9. 5 plus 4 is 9. And then we have 10. 10 is a 1 and a 0. Thank you, Lola, for the share. We can do it again. Well, guess what? Because I have this to be my ones place or this to be my ones place, I could choose any one of them, right? And so if I did this one to be my ones place, it would look like that. And then notice I won't have any more room for the hundreds. So we have our ones and our tens. But you know what? Because we can do that, we can actually make a really, really small number. We could do 0.00001. So we have a really, really small number. We're going to continue to keep this as my ones place, and I can show you what it looks like on Roman numerals. So 1 on the abacus, like that, right? It looks like 1 Roman numeral. 2, 1, 2, 1, 2. 3, that's what 3 looks like. And then 4, well, 4, because this is a 1 and a 5, right? 1 take away 5. But then 5, if you notice, 5 is the top bead. The 5 is the V for Roman numerals. Then 5 plus 1 is 6. 5 plus 1 is 6. Thank you, Crazy Train, for the share. And then we have 7. 5 plus 2 is 7. And then we have 8. 5 plus 3 is 8. And then we have 9. 5 plus 4 is 9. And then we have 10. 10 is a 1 and a 0. Yeah. Oh, that's fantastic, everybody. Thank you so much. We're almost at 4,000. If we could do 10,000, we would start going to multiplication, because we can do that on the abacus. And you can also do division, but division will be, I don't know. It will be the next mark. But thank you, everybody. Thank you so much for liking the live. I do appreciate that. I'm trying to get out to the world. I'm trying to introduce Abacus to the Matrix. Welcome, everybody.
Welcome to the real world.
I know, right? Only facts? It is super easy. Are you only facts like the fax machine? That is funny. All right. So I'm going to continue on. We have this. I have this. This is just talking about how to read the abacus. If you're looking for something a little bit more simpler, I do have one that is a 2-digit number. Depending on like the kids, right? So the kids, if the kids are young and maybe they're like first grade or second grade, I do have a 2-digit one. And we're just talking about the tens and the ones. And it's the same thing. You're just going to need to figure out what the answer is, and then you find what the path is. And then what you'll do, notice, it is crazy simple. Oh, I forgot to explain. Notice I have this mask maze. It's to cover up the maze so you don't see what the answer is. So no cheating. Anyways, because, our eyes can see all the answers. And I don't, and this is all done. But I give you this mask maze in the beginning of the book. And it's up to you if you want to download a better one. You can download and print it on a better piece of paper. And then here is explanation on how to read the abacus. So we have our big brain notes. We count from 0 to 1, and then I talk about 2 digits, and then we talk about 3 digits. And this is just a review of what 3 digits looks like, right? So if I did 824, 824 just looks like this, 824. So we have our top beat is a value of 5, and then we have 3. So 5 plus 3 is equal to 8, and then we have 2, and then we have 4. And then that's what it would look like, and that's why that would look like. Yeah, crazy simple. Crazy simple. Simple to use, easy to understand. So there's a whole bunch of mazes in this book that you can just go through. And then I give you this thing called a reverse maze. A reverse maze just means that that I give you the path, right? I give you the path. That's the path. And I give you the number, and it's up to you to color it in for what it is. So if this is 880, then you color in 880 on the abacus. That's what you're supposed to do. Okay? So when we're looking, like this one here, 307, so you color in 307 like that. That's it. All right. So that is this book right here. Thank you everybody for joining. Thank you everybody for joining. So I have a 3-digit maze. I have a 2-digit maze. If you think it's a little bit too complicated, I do have a 2-digit maze, which is the same, except it's talking about the 10s and the 1s, right? If you wanted to have something a little bit more challenging, I do have a 4-digit maze. So the 4-digit maze is exactly the same. I give you the how to read the abacus. We talk about the double digits, the triple digits, and then the quadruple digits. And we do a little review. I give you the mask maze, and here's the maze. So this is all done, but if I show you something like this, right, or something like, yeah, if I show you something like this, what number do we think that is? So, for those of you that are interested, I do have my books available over here. My name is Lynette, and I teach Abacus. I've been teaching Abacus for about 20 years now. So, we have our number. What number do you think that is? We have our thousands, our hundreds, our tens, and our ones. What number do we think that is? 600, 6,000, 700, 0, 8. Thank you, Jordan. Thank you, Crazy Train. Thank you, Lola. Yes. So when we're paying attention, hello, Chichiro. So when we're looking, we got. So if you look, Crazy Train, we have 7, not 8. And then that's what 9 is. So this is 6,809. That's what that looks like. But our question was this one, 6,700, not 8. All right, so that's what that number was. So then we have our next number. What number do we think this is? We have our thousands. Let's see. Okay, we have our thousands. We have our hundreds. We have our tens. And we have our ones. I'm learning multiplication today. If we could get to 10,000, you would be. If we could get to 10,000, everybody, we will be doing multiplication. Thank you, Lola. Yes, thank you. 1,834. Oh, maybe I should put a little thing up, right? If I put a little thing up, let's see. Let me do this. The goal is 10,000. The goal is 10,000 likes. So everybody can be a part of it. Yeah? We'll go into some multiplication. So then we have our next number. 1,830. Okay, yeah. 1,834. There we go. So 1,834. And then we have that number. Cool. What number do we think that is? We have our thousands, our tens, our ones. I'm sorry. We have our thousands, our hundreds, our tens, and our ones. Notice that some of the beads does not have the top bead touching. So when we're looking, we have this one, the 5 is not touching, but this one, the 5 is touching, right? Thank you, Lola. Yes, it is 3,383. Notice it kind of looks the same, but kind of doesn't. So when we're looking, we have to pay attention to the top bead. The top bead is not touching here, so that's why this is 3. 1, 1, 1, 1. When you can, could you show the other abacus in comparison to size? Oh yeah, we could do that right now. So for what Jordan's asking, I have a 13 column abacus. This one, like this one, the 13 column abacus is different than a 7 column abacus because size matters. Now, why would I want to do one over the other? Because if I wanted to use division, it's easier to do it on a 13 column abacus. But the 7 column abacus will be just sufficient enough as well. Because a lot of the numbers that we're working on is going to go probably up to five numbers. So when we have this, notice even in multiplication, depending on how big the multiplication is, you could still utilize all of these numbers. So we have our ones, our tens, our hundreds, our thousands, and our 10,000s. Jordan, is that what you were asking? The difference between the sizes? So if you notice, there's only 2 labels here. There's one over here and there's one over here. Whereas for this one, on the 13 column one, I can actually have multi dots, right? Multi labels, because any one of these labels can be my ones place. So what the dots use is the dots is for readability. So I can do my ones over here, then I have my thousands, and then I have my millions. If I wanted to, I could change my ones over here. So then my ones, my thousands, my millions, and then I can go billions. However, let's say I want to change my ones over here to the very end. Do you see how there's a dot here? So then I do ones, thousands, millions, billions, and then trillions. So what's the difference? The only difference is that one is colorful, one is not. And one just has more numbers, but it works exactly the same as each other. It just depends on what you're doing with it. So you could obviously, if you only want to have one abacus, I would recommend the 13 column abacus, because that would be sufficient for even the small numbers to the big numbers. But if you're okay with 2 abacus, then I would recommend the small one, because I like the color and it's nice to see the difference when the beads are touching. So like we know that this is 11, this is 22, this is 33, this is 44. Hello, Dawn. Thank you for the question. So when we're looking, right, and that would be the reason why I would do the smaller abacus. Also, with the smaller abacus, it's like the size of a phone, or this. If you look, it's just like the size of my hand. I don't have big hands, right? So it's the size of my hand. It's nice to have a pocket. It's like a pocket abacus. You could carry it around. With the 13 column one, it's a little bit longer, so it's a little bit harder to see. It's a little. I'm not hard to see. It's a little bit harder to carry around if you just want to carry it around. Oh, Dawn, you're so funny. Learning the abacus was not my bucket list today. Yes. Thank you, Crazy Train. Yes, I understand. Thank you, Dawn, for the question. You're so funny. You're so childish. All right, so we're going to continue on. So our answer was 338. Oh, and this is our final one. So we have our number, we have our thousands, we have our hundreds, we have our tens, and then we have our ones. Thank you. Hello, board. It is, thank you, 5,908. Yes, it is 5,908. Thank you. Board, did you finish your homework? I know you know, Crazy Train. I know you know, because it's just one of those things. Okay, and so then again, if you notice, there is the beginning, and then so this is when it's not colored in. This is when it's all colored in. The idea is to color it in so it makes it look nice and pretty. And then again, I give you the reverse maze. The reverse maze, if you notice, is you get the number and you have to put it in. You get the number and you have to, you can't even see that. There you go. So you get the number and you have to color in what the abacus is. That's what this is. And this is the reverse maze. The reverse maze is to for you to color in the abacus, because I think coloring is very peaceful. And then that's it. I do have answers in the back of the book. Oh, that's right. However, if you're interested in more than just reading, I do have an abacus for adults. This right here. So what this does is, coloring is definitely peaceful. It is, right? I do have, I don't know if it's in stock, but I do have a coloring book. I created a abacus coloring book. So this is, I just started this. I didn't just start it, but I started it. And so I just kind of, it is really quite relaxing. These are some of my designs. I'm just kind of trying to figure it out, you know? There we go. Yeah. And then it goes all the way, it goes individual. It goes by number, right? 15, 16, 17. And trying to find different ways to do it. Yeah. And then after like 30, it goes by tens. And then it goes to 100. Yep. There we go. I did chemistry from before the time. I'm joining the one earlier till 9. Oh, thanks. Thank you, RJ. Oops. So, I'm trying to get my coloring book in the shop. Apparently I sold out because I didn't think anybody would be interested. All right. So, woo! Oh, hey, Jordan, multiplication. Okay, so let me do a little run through on this one for those of you that are interested, and then we'll do some multiplication. Just in time, board for some multiplication. Well done, everybody. Well done. I can't believe you guys got to 10,000. Thank you, everybody. Thank you so much for going up to 10,000. Jordan, your wish. All right. So before I had to make a brochure. Hello, Jen. Hello, Jen. How are you doing? I really appreciate your review about your buying the thing. It's been a while. It's been a little bit. It's okay. It was at Phosphorus. Oh yeah. Okay. So So what am I doing? Let me do this. Let me do a real quick review, and then we would. Thank you. It really touched my heart. I hope your mom's doing better. Let me know if you need more exercises, and I will be happy to publish that out. So let me know if she enjoys anything specific, and let me know, and then I can accommodate. Of course. Okay, so this again is the introduction to Abacus for adults. This is just adding and subtracting, and then after this flip through, I'll go into some multiplication. But the first thing is to do is understand that we want to build confidence. We want to promote critical thinking. Abacus in itself is very interesting because what I do is Abacus gives you a foundation of the numbers. What we do is after understanding how to read, right? I give you some examples how to read. We start learning how to add and subtract on the Abacus. We move the beads to add. I give you this thing called pixel art, and this is the idea is you color it in, but the thing is these questions are super easy, but the idea is to be able to see the beads move. So this right here is 6. We want to do 6. I want to add the 3. When I add the 3, all I got to do is add the 3. That's what I gotta do. I might get this after this. It's very interesting and important. It is. It's very cool. I like it. And then, hold on. Okay. So, the idea, do the motions, because the idea is to see how the beads move, right? This is really easy. You could do this in your head. I know you can, but the idea is to be able to, watch the beads move. So here is 8 on the abacus. If I do 8 on the abacus, I want to take away 3. I'm going to take away 3. That's what I got to do. I'm going to hide this. There we go. So, did you know that when white phosphorus comes in contact to oxygen, it catches on fire? Oh, I didn't know that. It's been a while since I did chemistry. Thank you, board. Then we start talking about how to make a 5. So this is one of the core concepts, how to make a 5. And then once you know how to make a 5, you will know how to subtract the 5. After you subtract the 5, then we go into adding of the 10. After adding of the 10, we go into, this is the beginning parts of multiplication. Multiplication in the abacus is just repeated addition. So what we would do is we would do like the 4 times table. So we do 4 plus 1, and we would just be adding it, right? So 4 plus 1 is 4. 4 times 2 is another 4, so you add the 4 here. So add the 4 is plus the 5 minus the 1. And then we add 3 times 4 is add another 4 here. To add this 4, it's plus the 5 plus the 10 minus the 6. So what we're doing is we're understanding that. And then okay. And then this is the adding of the 10, and then we do subtracting of the 10, and then we do color by number. This is making of the 10, and then I give you a framework. The framework is how to read the beads and how and the path that goes. It's the workflow. Every number goes through this workflow. So when we're looking at it, it's always going to be this way. If you know how to add, you will know how to subtract. Because once you get into a 2-step, then that's where you start seeing the difference, right? You'll start Tetris away, you're through. And then here we have a puzzle. Answer the puzzle. Find the puzzle pieces. And then I give you a whole bunch of activities. That's what it is. And then if you know how to add the 2-step, there's a minus the 2-step. And then you start going into the mosaic and the addition. That's it. So this is my book. It is available, and I do have answers in the back of the book. Oh my God. Oh, this is stuff. It's more confusing. Oh, Luke. Someone's blowing you up. I know. It's my kid. All right. So thank you so much. Okay. Thank you so much for your patience. Let's get into some multiplication. Okay. We do multiplication. Let me find it. All right. So let's see. Let me find some multiplication. Sorry, I had to move my books. None of that. None of that. Here we go. Let's see. Oh, that'd be perfect. We'll do that. All right. Okay, perfect. Okay. Oh, see you later, Crazy Jane. Thank you so much. Thank you so much for dropping by. Thank you so much for checking in. I'll see you in my next live. All right. So, multiplication on the abacus. Here we go. Let's see. Now, I know you can do this in your head, but the idea is to be able to understand the concept. So in Abacus world, we do distributive property. What is distributive property? Distributive property means it's a math rule. It breaks the numbers up into smaller parts. So when we're looking at it, we're going to do, we'll do this. 994 times that by 2. Okay? I would be excited. Carlos! Hello, Carlos. Only I would be excited about an abacus at almost 1 in the morning. That's crazy. See, that's that's like the craziest thing, right? Like it's it's way past your bedtime, and we're talking about math in the middle of the night. So in Abacus world, what we need to do is we need to figure out where we're going to put our product. So we count the amount of digits. We have 1, 2, 3. 1, 2, 3. So we know it's going to be in the hundreds, right? That's how we counted it. Does that make sense? Thank you, board. So, and then what we do is we do distributive property. We go 2 times 9. 2, what's 2 times 9? 2 times 9 is 18. Thank you, board. It is 1. It is 8. Thank you, Lola. Thank you, Jordan. Right? Easy. And then, so that's 18. And then we do 2 times 4. 2 times 4 is what? 2 times 4 is 8. Thank you, board. So now we get into what happens. Because 8 is a single digit, we actually have to change this to a double digit. That's what we need to do. Why? Well, because we need to push the number over. And it's not a foreign concept. It's not a foreign concept to make a single digit a double digit. So what we want to do is a 0, 3, 0, 4. Anytime it's a single digit, you want to make it a double digit. So the other places that we do double digits is in time. If you look, it is 11:03, or it's 05, 06, 11. This would be the date, right? So it'd be May 6 of 2011. Or we could talk about it in money. $2.05. So this 0 is not a foreign concept. So that's why we want to make this over here. Make sense? Thank you. So it pushes my number over. It would be a 0 and then 8. So what is my final answer? What is my final answer? Thank you, board. It is 188. Did that make sense, Jordan? Thank you, Jordan. So we could do another one. Thank you, Jen. So we could do another one. Let's do another one. So we have our next one is 775. Now, when you look at it, again, we're in exactly the same. We're going to count the amount of numbers. We have 1, 2, 3. So we have 3 digits. We're over here. So we count. What is 5 times 7? 5 times 7 is, thank you, board, yes, 35. And then we do it again. We said 35. And then we do it again. 35. So what's my final answer? Easy, right? Thank you, Jordan. Thank you. Oh, ooh. Oh my God. Yes, it is 385. Thank you, Jordan. Thank you, board. Thank you, Jen. Easy? So then we can do this one. Same thing. One, two, three. There we go. Okay, see you later, board. We'll do 3 digits. 1, 2, 3. So we do 4 times 7. 7 times 4 is... Do you help with other subjects? No. If you want help with prime factorization, and I believe that's algebra, Audrey does that. DM me and I can send you to Audrey. What number, what's our product? So we want 4 times 7. What is 4 times 7? Thank you, Jen. It is 28. Add the 2, add the 8. Right? And then what? 4 times 4. 4 times 4 is... $16. Thank you. 16. Add the 1, add the 6. Okay. So now, that's how you do multiplication. That's the beginning parts of multiplication. Now, I know Jen knows. Jordan, do you know your multiplication fact? Do you know your fact families? I don't remember. I don't remember where I left off, everybody. So, Jordan, you know your fact families, right? You know how to make a 5 and you know how to make a 10, right? Jordan, in my head, I'm in my head putting a 0 behind the product of multiplying in the tens position. You could, but we don't have to in Abacus world. You could do this, But see, the thing is we don't need to do this in Abacus world because our Abacus tracks it for us. So when we're looking, we do 280, but on the Abacus, we just do 28. Do you see that? Hello, yes, man. I was watching. Does that make sense, Jordan? So you could put it in the tens. It's not a problem, but you don't have to. That's why Abacus makes it into manageable chunks. So we only need to know our multiplication fact. Does that make sense? We only need to know what 28 is. We don't need to know what 280 is. Hello, Abraham. Yeah, totally unrelated. Oh, thanks. Yeah, it's weird to skip a step, but I do it in my head. That's fine. But you know what? It gets more complicated. Wait, before I go on, we can do something more. We could do something a little bit more. Oh, I'm having drama with my friend. Oh, okay. You know how to do this, right, Jordan? You know how to make a 5 and make a 10? Because when we start getting into... Yeah, okay, good. So then when the numbers get more complicated, right, we can do 3, I don't know, 2, 4, 7, 8, times that by 3, 2. 1, 2, 3, 4, 5, 6. So we'll do it slowly. We do 6, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we start here. 3 times 6. 3 times 2 is equal to 6. 6 is a single digit. Hello, Lexi. Hello, Lexi. How are you going? How you doing? It's a 0 and a 6. 3 times 4. What's 3 times 4? I'm sorry, 3 times 4. What's 3 times 4? 12. Thank you, Christine. It is 12. It is a 1. It is 2, right? And then we do 3 times 7. 3 times 7 is, thank you, everybody. Thank you, Christine, Ale, Mel, Jordan, Christine. Yes, it is 21. Add the 2, add the 1. And then 3 times 8. 3 times 8 is, thank you, Zay, and thank you, Busy. Thank you, TF. What is 3 times 8? 3 times 8 is 24. Thank you, 24. Add the 2, add the 4. So we're done with the 3, right? And then what's going to happen is we're going to recount. When we recount, we do 1, 2, 3, 4, 5. So we go 5. So we go 1, 2, 3, 4, 5. Now it gets a little crazy because we're going to have to start knowing our fact families. So we have 2 times 2 is equal to what? What is 2 times 2 equal to? 1, 2, 3, 4, 5. Thank you, 4, right? I want to add 4 here. To add the 4, we need to plus the 10 minus the 6. Plus the 10 minus the 6. That's not right. You know why? Because we need to make it a 0, 4. Right? We need to make it a 0, 4 because it's a single digit. So it's a 0 and then a 4. How do we add the 4 here? I have to slow down. How do we add 4 to this column? I want to add the 4. Is there enough? No. What do I do? Thank you, Jen. Plus the 5 minus the 1. Plus the 5 minus the 1. Next to the right. Yes. Well, next row to the right. 5 down. Yes. Good. So then we do 2 times 4. 2 times 4 is equal to what? What is 2 times 4? Oh, I can't move that. What's 2 times 4? Thank you, Jordan. 5 down. Yes. 8. 8 is what? Thank you, Jen. 8's a single digit. So you go back 1 column, you add the 8. So 8 is what? 8. How do you add the 8 here? Plus the 8 is equal to... What is plus the 8? How do we add the 8? It's not 16. Thank you. Plus 10 minus 2. Plus the 10 minus the 2. And then we have to do 2 times 7. 2 times 7 is equal to what? Thank you, Jordan. Well done. So what is 2 times 7? 2 times 7 is 14. 14. Add the 1. Can we do it? Add the 4. Add the 1. Can we do it? Yeah. We can add the 1 here, right? We want to add 4. Cannot add the 4. What do we do here? We cannot add the 4 here. What do we do? Plus 4 is equal to what? Plus 4 is equal to plus the 5 minus 1. Plus the 5 minus the 1. Good. And then our next one is 8 times 2. What is 8 times 2? 8 times 2? Oh yeah, good. Thank you, Busy. Thank you, Jordan. What is 8 times 2? 8 times 2 is 16. Thank you. It is equal to 16. So I add my 1, I add my 6. Whoa. So what is my final answer? Right? So my final answer is, how do we read that? So we have our ones, our tens, hundreds, thousands, and then 10,000s. What number is that? So we have 5. Hello, Cool Rubbish. Welcome back. Thank you, Jen. It is 7 over here. 5 plus 2 is equal to 7. So this is 7. And then we have the thousands. So this is 10,000. This is thousands. 5 plus 4. The top is the value of 5, and we have 4. 1, 2, 3, 4. 5 plus 4 is equal to 9. We're going to put our comma here, and then we have 2. So 2 is right here. 1 and a 2. So 2 goes over here, and then again, 5 plus 4, 5 plus 4 is equal to 9, and then we have the next one. The last one in my ones place is 6. 5 plus 1 is equal to 6. 5 plus 1 is equal to 6. Thank you, Jordan. Thank you, Jen. So when we're looking at it, it is 79,296. Thank you, your mom. So when we're looking at it, we actually do distributive property, and it doesn't matter. So that's what I was trying to tell you, Jordan. Don't worry about the zeros at the end, because it's going to get you more confused, right? Because in the Abacus, if you did this, you would have to do like 30 times 2,000. And then you'd have to do 30 times 400. And then you have to do 30 times 70. And then 30 times 8. Right? So the problem with this is all of these zeros will get you really confused. Just take it with what we have. We understand our multiplication table. Make sense? So with the multiplication table, make it simple. It's simple, simple, simple. Don't make it too extravagant. Don't make it too big. You know what I mean? Yeah. The zeros can stay in my head. The zero, yeah. I be careful with the zeros. Be careful with the zeros when it comes to multiplication, because you can get really confusing really quick. Because you don't want to put too many zeros on the abacus. Yeah. You know what I mean? So, you could still do you could still do 3. What do you mean? You could, my little thingy, my little that's funny. I changed it already. I changed it just for you. So, thank you everybody for joining. Thank you everybody. What is this thing? This thing is an abacus. This abacus is a counting tool. So what we just did is I just showed you what multiplication is on the abacus. And let's do a little review on how to read the abacus. Thank you everybody for joining. We have 130 people in the room. Thank you everybody for joining. So we're going to do 1, 2, 3, 4. Every time the beads are touching the horizontal bar, it is considered counted. So there's 4 over here. Sorry. Oh my gosh. Okay. So this is 4. The top is a value of 5, right? And then we have 6, 7. 5 plus 2 is 7. 5 plus 3 is 8. 5 plus 4 is 9. And then we have 10. 10 is a 1 and a 0. There we go. What? Hey, Jen, what activities have you done, or has your mother done? I'm really curious. Because I know a lot of people like the mazes, and so I was gonna my multiplication book will be a maze book, and then I was told that some people want to do 5-digit, 6-digit, 7-digit mazes. The mazes, really? Okay, I gotta go to bed. Feeling good. Have a good feeling. Sorry. Have a. Thank you so much, Jordan. Thank you so much. I will see you in my next live.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
Does it start from there, or can you start from anywhere? Oh, that's a very good question. I usually start where the label is. There's a label right here. This is my ones label. And so what I would do is I would line it up with my ones place. So we have our ones, our tens, our hundreds, our thousands, and our 10,000s. And then we have our decimal sits right here. So we have our tenths and we have our hundredths. I'll be back. Okay, Jordan. So yeah, it's crazy. People were like, let's do the mazes, but instead of 4 digits, they wanted bigger numbers. And I'm like, really? They wanted bigger numbers? So I got to do a 5, 6, and 7-digit abacus maze. Yeah, that's what I was going to do. That's that's the next book that I'm going to do. Yeah, all right. And then I just found out today that the kids don't need to memorize anything higher than 10 times 10, which is still dumb because 10 times 10 is just redundant. They should go just to 9, but it is what it is. All right, so we're going to continue on. Thank you, everybody, for joining. Thank you, everybody, for joining. We'll do this. We'll do this. There we go. Hello, birds person. Thank you. So we have our number. If you notice, I have my ones over my thousands. This is for readability. So we have our 3,456. Yeah. So what's the next dot? Thousands. So it's for readability. Just like the thousands over here, just like the comma. So we have 3,456. And then we can take it one step further. We can do 73,456.25. Yep, makes sense? So then we can have this number right here. I made it back. You made it back. I made it back.
55 burgers, 55 fries, 55 tacos, 55 pies, 55 cokes, 55 wings, 55 shakes, 55 pancakes, 55 pasta, 55 peppers, and 155 taters.
So when we're looking, this is 55,555.55. And then we can have like a whole row of 6. We can have a whole row of 8s. We can even have a whole row of 9s. So guess what? I'll help you with this number.
99 problems, but a ain't one. If you having girl problems, I feel bad for you, son. I got 99 problems, but a ain't one. Hit me.
99,999.99. That's what that would be. Oh, hello, unknown. Welcome back. Welcome back. Does that make sense, Goose? So when we're looking, right, it's the same thing with the decimals, or the tally marks. And that's what we're doing. So if we did the tally marks, we do 1, 2, 3, 4, 5. That's 5. We have 6. 5 plus 1 is 6. 5 plus 1 is 6. We have 7. 5 plus 2 is 7. And then we have 8. 5 plus 3 is 8. And then we have 9. 5 plus 4 is 9. And then 10 is a 1. right? 10 is a 1 and a 0. This is not 10. This is 55. We don't combine the two. Hello, board. This is going to be part of my dating requirements. Don't forget the 0, 1. Oh, yeah, that's right. So if I wanted to 1 and thousands, but then what I can do is I can actually change this one to be my ones place. So my ones place, I'd shift everything over and I'd say this is my ones. So we can actually have a really, really small number. We can have 0.00001. Oh, can't see that. There we go. That's because I did that, right? So we can have a really, really small number. What's going to be the dating requirement? That they know Abacus? Oh, that's funny. Thank you, everybody. Thank you, 99 Jen, for sharing the live. That's funny. That's really funny. All right, so we're going to continue on. It's just like, because we're going to use this one as the ones place, we can talk about Roman numerals. We can do 1, 2, 3, 4. Well, 1, 2, 3, 4, right? 5. The 5 is always a V, right? The V on the top, like that. And then we have 6. 5 plus 1 is 6. 5 plus 1 is 6. 7. 5 plus 2 is 7. And then here, 8. 5 plus 3 is 8. And then 5 plus 9. 5 plus 4 is 9. And then 10 is just a 1 and a 0. Does the soundbite from Drive-Thru sound like Tom Hanks? Is that soundbite from the Drive-Thru Tom Hanks? What Drive-Thru? Could you show us? I'm back. Are we doing multiplication division? Can you divide on it? Yes, you can divide on it. Hello, Machiavelli. 55 burgers. No, that one is not Tom Hanks. That's Tom Robbins. Yeah, that's a separate skit altogether. And that one came from, I don't, he's not an SNL person. So, are we still doing multiplication? I haven't done multiplication. I'm actually doing some adding and subtracting right now. How do you use this mystical tool? It's magic. What can't you use it for? Everything else? Sounds like him. Oh yeah, it does sound like him. You can't do algebra. I mean, anything higher. The only thing you can do on the abacus is adding, subtracting, multiplying, and dividing. That's all you can do with it. Can you divide on it? Yes, you can divide on it. Okay. Are we? We're not doing multiplication. We're back to adding and subtracting because we have some new people that's in here. So when we're looking, we're just going to do another review. So it does sound like him. But he was like spewing. So we have our 1, 2, 3, 4, 5. The top is the value of 5. We have 6, 7. 5 plus 2 is 7. 8. 5 plus 3 is 8. And then 9. 5 plus 4 is 9. And then 10 is not this. Because every column is represented by every number. This is 5, this is 5, this is 55. This is 10. This is a 1 and a 0. 1, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There we go. I don't know if Cake has been following. Does that make sense? So we can count and then we can go into hundreds. So we have our ones, tens, hundreds, thousands, and then 10,000s. That's it. Okay. Thank you everybody for liking the live. Hello, yes, man. We're not doing division right now. Because we're going to go into some... We're going to go into some what? We're going to go into some adding. Oh, yeah. Oh, I don't know. Okay, yeah. You know, I'm going to show you this. Did Jen, who invented that? I don't know, Alan. I don't know who invented it. I don't know if one person invented it. I think it just kind of happened. It happened in the Mesopotamia. Um, uh, I don't know if Michael knows. Michael and Jen, do you know there's this other? I'm going to make this book into a dry erase, and what it is, I don't know if I showed this to you. We're going to be doing adding sequentially from 1 to 100. I asked you if you did this. I don't know if you understood the message. So what it is we add the 1. We're going to add 1 on the abacus. We want to add 2, so we add the 2. And then we add the 3. Can't add the 3. So guess what? You're going to have to use a formula. Plus the 5 minus the 2. And then we add the 4 plus the 5 minus the 2. Oh, sorry. There we go. We add the 4. It's plus the 10 minus the 6. I didn't understand what you asked. Oh, okay. So this is what it is adding sequentially. So what we're doing is we're just adding all of these numbers in sequential order. So add the 4, add the 5 as a running total. So right now my total is 10, and I want to add the 5. It becomes 15. And then I have another one, which is 16. 6. Add the 6. Adding the 6 is what? Plus the 10 minus the 4. Plus the 10 minus the 4. Minus the 4 is minus the 5 plus the 1. So this becomes 21. So what we're doing is we're adding in sequential order, right? And so then we have a running total over here. So that was the exercise. And this is going to be one of my new books. We have 21, and then there's going to be a beginning skill, intermediate skill, and an advanced skill. Yeah, I think I missed you showing that book. I haven't. I just started showing it off because I think I figured out my format. And so this one's going to be a dry erase where you can use the big fat markers, and then if you make a mistake, obviously you could erase it out. But then the other one's going to be a printed book. So I was going to actually have a printed book. I didn't print out the format, but it's going to look something like this. Yeah. It's very, funny. It's very, if you really get into it, it's really kind of meditating. And you just keep going. So here we want to add the 7. All you got to do is add the 7, right? And then we want to add the 8. To add the 8, what do? We have no more room to add the 8. What do? So we know we have to plus the 8 is equal to plus the 10 minus the 2. Plus the 10 minus the 2. So my final answer is, my running total right now is 36. And then I want to add the 9. Adding the 9 to here. Can I add it? No. Plus the 9 is equal to plus the 10 minus the 1. So I plus the 10 minus the 1. So my answer is 45. And then I need to plus 10 here. Plus 10 is plus the 1 is equal to plus the 5 minus the 4. So plus the 5 minus the 4. So right now I have 55. So that would be the running total. And then it just keeps going. So we have, this is the 10. This is, up to 20, up to 30. And this is really to get you to exercise your fact families. Your 10 fact family and your 5 fact family. It's really quite interesting on how everything goes. And it gets really, really crazy towards the end, like this. And so obviously I was going to give you the answers, but this is for you to fill out. And then there's the answers, and this is the running total. The final total is 50-50, which is crazy. Yeah, the formulas, right? Yeah, those are the formulas. So like this one right here, we'll do here, this one. And this is what I call advanced advanced adding, because there's a lot of formulas that are involved. So we have this one right here. We could do 4, 7, 5, 3 plus 98, right? It's actually really quite meditative. I did it once, and then I was like, I'm going to make a book out of it. So we have our number, right? This is towards the end. we have 4,756, 7,000, I'm sorry, 4,753. And then we want to add the 9. When we add the 9, what do we do? To add the 9, what do we do? Plus the 9 equals plus the 10 minus the 1. So we plus the 10 minus the 1. Plus the 10, right? And we need to minus the 1. Cannot take away the 1. What do we do? Minus the 1 is what? Minus the 1 is equal to minus the 5 plus the 4. Minus the 5 plus the 4. And then we want to plus the 8. Cannot add the 8 here. What do we do? Plus 8 is equal to plus the 10 minus the 2. Minus the 2 plus the 10. Cannot plus the 10 here. We have to plus the 1 is equal to plus the 5 minus the 4. Plus the 5 minus the 4. So my answer right now is going to be 4,856. 4,851. Sorry. 4,851. Yeah. But it gets crazy. It gets crazy. It's very interesting, right? And it gets crazy, like, because there's all these things that you have to, like, keep track of. And I think it's really interesting. Yeah. But that's one of the books. This will be a dry erase book. So then you can, keep practicing. It's one of those activities. It's like a warm-up activity that we give to the kids. My kid was like, "That's like a trash exercise." I'm like, "It's not trash. It's actually quite interesting. It's just really meditative if you really enjoy that sort of stuff." Hello, thank you, Machiavelli, for the share. Did that make sense? That was one of the things. And then because you can add from 1 to 100. Then you can do it the other way. Go backwards. Go 100 to 1. So you add the 100, you add the 99, you add the 98, and you just go all the way down till you get to 50-50. 5,500 is the final answer. And then there's a subtraction. So there's subtraction from 50-50, you minus the 1, minus the 2, minus the 3. And you go all the way till you get to 0. And obviously, if you can go this way, you can go the other way. Minus 100 to 1. So it's 50-50 minus 100, minus 99, minus 98, and then minus 97. Every class is very stimulating, and I sleep well every time. Love learning new things. Oh, really? Hello, Mei Lin. That's really helpful. Really? I thought it was a really interesting exercise. Welcome. Welcome, Mei Lin. Hello. Yeah, that was this is going to be my next book. I have a few books that I'm actually going to publish. And so once I get this out the door, then I can start working on the multiplication and the division one. I do feel more comfortable with the division one. I realize that I do explain it well enough that I'm comfortable with publishing. Haha, nice. Oh, thank you. Yeah, it was one of those things. It was very meditative. And I was just explaining like the book itself. So there was going to be 2 books. There was going to be a printed book, and then there was going to be a dry erase book. So this one was going to be a dry erase book from addition 1 to 100. And what it is just add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 all the way to 100. And it just depends, and you get like really crazy. My nightmare would be if almost done when my dog walks by and knocks the abacus on the ground. Well, that's why I give you a space for you to write the running total. You will have a space to write the running total. But it does get really, I think it was pretty meditative. I was working on this when I was out fishing. When the boys were out fishing, I was actually working on this. I was like, oh, this is actually really kind of nice. But I like to break it up. Yeah. And that's what it'll be. You'll get the running total, but it'll come in like different skill levels. So the printed book is going to be something like this, and the skill level is going to be beginner, intermediate, and advanced. And I think that will be a pretty good book. I think I'm just about done. So those will be 2 right there. And it's going to be pretty hefty. Yeah. Oh, I'm excited. I'm excited for it. But you know what? I actually need to do it. So like this one, because I need to write the answers. I have to write the answers. To go through all of this, I write the answers all by myself. And so I go through each one. I try to answer it correctly. So hopefully it's turned out right. So we did. So my next one is 9394. I have an old abacus from China. Oh, hey, Carrie's. That's fantastic. You have something like this. So it works exactly. It works very similar to the Japanese abacus. So on the Japanese abacus, right, we can count from 1 to 10. But on the Chinese one, it's the same, sort of the same. So we have 1, 2, 3, 4, 5, and then we have, because we have 5 here, we're going to trade it in to this. That's what 5 looks like. And then we have 6, 7, 8, 9, 10. We're going to trade this in to make it up here. So that's 10. So because this is 10, we're going to trade that into this. So now we have 10. Do you know, Carrie, do you know how to use the abacus? And I forgot, is it a 2 beads on top or is it a 1 bead on top? Because there's difference. Some people know how to do it with the 1 bead on top. Some people know how to do it with the 2 beads on top. The ones in the 1 bead on top is more modern. It's been around since the 1600s. 1600s. Yep. And then this one here is before. It's like the 9000. Would the abacus use less formulas? Yeah. I learned to use it many years ago, but I've forgotten it. Yeah, this one would be different. So if we did, it would be less formulas. Actually, the Chinese one doesn't use any formulas, which is interesting. So the Chinese one, what they do is they count up. So if I did 3 plus 7, you just add like that. So this is 10, so that would be 10, that would be 10. So there was a 7. Let's do 7. So the question was 7 plus 7. Well, adding of the 7 is what? Plus the 7 is plus the 5 plus the 2. Bring it together. This is 14. So we have 2 right here. That would be 10. So it would be 14. 1 bead on top. Oh, that's perfect. So then with this one, I actually have a bunch of activities in my TikTok shop that does that you can use the abacus with. And you can remember. And I give you a whole instructions on how to use it. So this is my one book that I have. This is my latest book. This is the Adding and Subtracting, Building Confidence and Promotes Critical Thinking for Adults. So Carries, do you know how to multiply and divide on the abacus? And then we start talking about how to read the abacus. And after we read the abacus, then we start going into adding and subtracting. Making of the 5, add the 5, take away the 5, add the 10, take away the 10. And then what I call a two-step equation, which is more like mixed formulas. I don't know if they taught you mixed formulas. So it's like, I'm not sure what terminology you used. Maybe like big friends, little friends, big friends, small friends. And then I have all these activities that you can go through, just to remember. And I have answers in the back of the book. Not sure if the beads are bone or plastic. My stretch goal would be to use imaginary abacus and use the account. I doubt I'll get there. You know, it depends on if you practice enough. I think you could do it if you practice enough. It's 11 rows across. That's really interesting. I have a 13 one that's go across. So it is possible. This one's a 7. And this is a 13. That's the difference. That's the only difference, is that one is bigger than the other. The colors mean nothing, so you know that. I don't think there'd be bone. It might be bone, or it could be really good plastic. Or it could be like some sort of ceramic or something. Yeah. All right. The beads are off-white. Ooh, I hope they're not ivory. That would be, yeah. Wood. The wood. Yeah, the one I have is wood. I have this one. I do have other ones. This is made out of bamboo and they just colored it. And then there's this one. And it's kind of it's a nice pinkish, but I don't think I think this is plastic. And these ones are kind of old too. Yeah, and this moves very well. So yeah, this is the pink one. And this is plastic. It's not that expensive. What else? I think those are the only ones I have. Oh, you know what? No. Let's see if I can find one. I think I have one that's 11. I have something like this, but it's kind of yellowish. I don't know if that's what I have. I do have an ivory next, which makes me sad to think about it. Yeah. This one I think is still plastic. I think this one's still plastic. This one is made out of Japan. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 11. Yeah, this is 11 bead. But it's kind of yellowish. So I think it's plastic. Yeah. Yeah. That's what I got. And there's still the dots. Do you have the dots? Yeah, the dots are still there. This is the ones, the tens. No, the ones, the thousands, and the 10,000s. They work exactly the same. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Yeah. All right. So let me put this back. All right. Okay. So, whoa. Dots on one side but not on the other. My mom was born in China. Oh, interesting. The dots are on one side but not on the other. That's interesting. That's interesting. So yeah, I mean, I have books if you want to jog your memory. All right. So I think I'm about done. I've been on for a little bit. Your Tristan. That's very racist. It's very, very interesting. Please do an ASMR. Okay, I'll do one post that was that will be an ASMR. I was thinking about it too. I was thinking about doing an ASMR one. But I'll have to get a different one that makes a little bit more sound. Yay! Yeah. I will. Okay, I'll do that. And then, yeah, I was gonna. So rude. I know, right? Tristan's like vanilla ice. Tristan looks like a vanilla ice. But Tristan only has 4 followers. No, sorry. 11 followers. Anyways. All right. I should go before it gets too bad. Hello, Michael R. Yes, thank you. Thank you. You have to find it. There we go.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
I like how I like how I like how he laughs at the end. Jim Carrey. I like how Jim Carrey laughs at the end. But yeah. All right. Okay. I'm about done. I should get to bed so I can get back up in the morning. That's my goal. My goal is to try to get in a little earlier and then leave a little earlier, so we can so I can try to hit the people in the morning. Thank you. Yes, man. Thank you. Good night. We'll try again next time with the multiplication division. Thank you. Thank you, Jen. It feels so weird, but thank you.
We are so glad you came. Bye-bye. 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 Bye-bye now. Bye. Bye-bye. Remember, please discard all candy wrappers and popcorn containers in the nearest trash receptacle. Thank you. Okay, bye-bye now. Bye-bye. Bye. Okay. Are they all gone? Is everybody gone? Huh? Good. Oh my gosh, my cheeks are killing me. I can't keep smiling like this anymore. I am exhausted. I think I need a break. A little break? Okay.
Still here.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
All right, Michael. All right. I will try to remember. I'll try to remember that if we do multiplication and division, that to invite you. I will try to remember. It's gonna be better once I get the book out. You too. Okay, Jen. Once I get the book out, I'll be more inclined to do multiplication division. But I don't have the book yet, so that's why I'm kind of like holding back a little bit, just because I don't have it. Okay, I will work on the multiplication division so I can make my lives better. Just for you guys. So much pressure. So much pressure. All right. Have a good night, everybody. Thank you so much. See you all in my next live. Bye.